Hi everyone, I am Devanshu and today we'll talk about databases and understand the factors we need to keep in mind when we want to actually implement a database and when we want to choose a database for our use case. Let's start from the basics. What is a database? It is an organized collection of data. The core functionality the database should support is that you should be able to store data. That is the baseline. Once stored, there should be a way to get the data back, either in the same form you inserted or with some processing done on that data. There should also be some mechanism in place to update/delete the data. Now, let me pose a question. Is your Windows file system a database as well? Because if you notice, it supports all these three operations, all these functionalities. You can store the data. When required, you can access that data, or you can also search the data by using the search bar. And then once you're done with that data, you can of course delete that file as well. In some loose sense, it actually is a database, but in general sense, we don't really associate that term with uh, the Windows file system. We actually call it a file system. But I guess you get the core idea that I'm trying to pose here. Now let's separate these functions into different layers. There should be a storage layer, a query layer, and an administration layer. The storage layer will define the schema of the data to be stored. For example, let's say if you want to store tables, or you want to store key value pairs, or you want to store key object pairs, XML, JSONs, graphs, you need to define that what type of data that has to be stored. The next thing that you need to do is define the operations you want to support in that data. For example, let's say you want to store logs that are generated by some server that you have. Then you don't need to support update on the data. As for logs, nobody wants to go back and then modify those logs. Delete can be bulk delete and not point delete. You don't have to specifically support deleting one particular log line from all the logs that you have stored. You could just support deleting a uh, bunch of logs together. That is what bulk delete will mean. And same goes for insert. We can only support bulk inserts since almost always the logs are generated at a very high speed. If you're going to go ahead and keep inserting all the logs one by one, it's going to be super slow. So it's okay to support only bulk inserts rather than point inserts. Then there is a query layer. Since you have the data stored, you have to define how do you get the data back and what type of queries do you support. In example of logs, you almost never want the actual raw logs back. Instead, you want some type of aggregation done to that data. In SQL terms, some group by functions to be applied on that data. Hence, if you're using or implementing a database to ingest logs, you should support fast aggregation queries. One other example is in terms of relational databases, where you store tabular data. What type of operations do you actually see supported there? You do selects, you do group by, you can do joins, etc. In earlier days of relational table, not everything that is present today was supported. Let me give you an example on this to show you how the development has gone on to include more types of query that can be supported. So this is a Wikipedia page for SQL, which is standard query language. So if you notice, we are looking at the history, and as you see, it was formalized in 1986, and it is only in 1999 they added the regular expression matching and the recursive queries and the triggers. And it was only in 2003 they introduced XML related features, and even more in 2016 they added JSON related functionalities. Then there's a final layer called administration layer. It takes care of authorization, authentication, helps in enforcing the data security, performance, data integrity, how multiple people access the data concurrently, how do you make sure the data is back up if the system fails, and so on. It's a huge layer, and a lot of things go on in this, but for now we'll not talk much on this. Hence the next question is, how do you implement a database? A very simple way to go ahead is to just define what things you want to support in each layer, what type of data you want to store, what once you have decided that, how do you want to store that data, what type of data structure do you want to use to store that data, and the associated metadata, what type of operations you want to support on the data, be it insert, and in insert, like is it a point insert or is a bulk insert, same goes for update, same goes for deletes. Then the next question comes up is what type of query you want to support. The way you store the data impacts the performance of the queries you support and the way you would be able to scale your database. The way in which you allow the modifications of stored data, it will also impact the queries as well. So you see that all these things are very interrelated to each other, and decisions in one part affects decisions that you have to take in other parts. For example, let's go back to us storing application logs. We almost always want to have want aggregated results in terms of logs. So how do you achieve that? You do some pre-processing ahead of time so that when the time comes for the queries you can do them faster. But what if you were to update some logs, which means that those aggregated results are no longer valid, which, and hence you need to again recalculate it. You see the performance hit this will cause. I think we are getting a feeling that all these factors are super interrelated, and decision in one area will have far-reaching consequences. Next, the question comes up about scaling. The amount of data that you are going to store in database is increasing day by day. So there are two things that you need to scale. You need to scale the rate at which you are ingesting the data, and then once you have a lot of data, how do you make sure that the query latency that you have is also not super big. Let's take an example of SQLite. It's a single file database. We can use it as in-memory database as well. Although the name has light in it, it still supports full featured SQL specification, and we'll talk about what that means in some time. It has a serverless architecture, which means that there is no concept of client and server with respect to this SQLite database. It supports ACID transactions even after power loss. So these are some of its features. Let's look at what SQL specification mean, and then we'll go ahead with this. And well, rightly so, they do say that in the documentation. Don't be misled by the light in the name. So if you see, it has implementation for tables, indexes, triggers, views, everything that you use in a SQL database. Multi-column indexes, you can have unlimited rows, 32k columns, you have all those foreign key constraints, uniqueness, ACID transactions, you even have, so you get the feel. We have, it supports everything that any other relational database will support. This is what is meant by full featured SQL. Let's ask all those questions that we asked before, and let's try to get a feel that how does these questions help us in understanding this database. The first question, what is the type of data you want to store? The data being stored is relational data in form of tables. How do you want to store that data? So this particular DB utilizes B trees to store data. Whatever operations you want to support on the data, ACID transactions even after power loss, what type of query you want to support. This database supports anything that is supported by any other SQL database, and it does a good job at that as well. How do you scale? Since it is a single file database and serverless, the scaling will mostly go vertical. It is limited by the RAM and the disk space that is present in the system. You just cannot store 100 TB of data on it. My intention here was to make you understand that every decision, every operation supported impacts the design of the database. In the next video, we'll discuss architecture of SQLite and understand the components that it has. And I'm sure you will be able to relate uh, to any database, any other architecture that I discuss, if you ask these questions to yourself that we discussed today. Thanks for watching, and do like and subscribe.